Hello, welcome to Calculus BC. Today we're going to take a look at limits. Now, I know most of you guys have talked about limits in your pre-calc class, so we won't take too much of time on this one, but I just want to go over some ideas about what exactly is what we call the limit of a function. So, a nice example, like imagine you want to go home and you tell your parents you're dropping out of school. What would they say? Well, I've had students say they would die, that their parents would kill them. Well, we can write this as kind of like a function. If you drop out of school, you will die. So we can say like f of dropping out equals death. That's kind of like a function. If you drop out, you will die because your parents are going to be so mad at you. But now let's try something different. Rather than saying that you are dropping out, let's now imagine not dropping out, but let's now imagine going home and asking parents what would happen if you were to drop out. Well, of course, they would still be mad at you, but you're not actually dropping out this time. But they would say something like this: if you drop out, if you drop out, then you would die. So, what's nice about the word if for us mathematically is it allows us to find out what would happen if we could do something, even though we're not actually going to do it. So, So that latter question is very interesting to us mathematically. Is that, like I said, it's going to allow us to find out what would happen if you were to drop out without actually having to drop out. So you kind of know the consequences before you take on that action. So how do we use this mathematically? Well, let's say we're given the following rational function, 2x divided by x squared minus 2x. Now, if we try to plug in 0, we would get 0 over 0. Now, here's a big thing. We never write this. Okay, we're going to talk more about this way later on. We never write 0 over 0, even though everybody else does. The AP hates it. Now, but the problem is 0 over 0 does not tell us too much about the actual solution. For example, if I were to say, what is 0 divided by 0? Well, you could say something like, well, 0 over 0, any number divided by itself is 1. But somebody else might argue, if you take 0 divided by any number, you're going to get 0. But wait, in pre-cal and algebra 2, you said if you take any number divided by 0, you get something that does not exist. Notice we always write that D and E. We'll talk about that too. We get something that does not exist. So if we take 0 divided by 0, we have three different solutions. Now, in pre-cal last year, you said something like this was considered indeterminate. And because we don't really know exactly what it is. So let's look at the graph. Now, if we look at the graph here as the function approaches 0, as we get closer to 0, remember the y-axis, it looks like the value is actually approaching -1. This is what we call a limit. We can't physically plug in 0. For example, if we try to plug it in, we would get something like f of 0 is, well, we don't know because I can't plug it in. We would get that 0 over 0 right here. So since we can't plug in 0, 0, we really wouldn't know what it is. So what limits allow us to do says, well, if we approach 0, so if x is approaching 0, as you wrote this notation in pre-cal last year, as x is approaches 0, it looks like the function approaches -1. And that's what that little arrow means. That little arrow means for us approaches. So we're not actually going to reach, if we look at the graph over here, as we approach 0, we're never going to actually equal -1, but it looks like we're going to approach -1. So a real quick hint there is that the limit that we found here, it's not actually finding the value, but what it's doing is it's asking what would the value be if the value existed. So what we're really saying here is if f of 0 could exist, it would be -1. So if it could exist, it would be -1. That's like saying if dragons were real, I would be hiding underground. But they don't exist, so here I really am. But the word if for us mathematically here allows us to find out what would be the value of the function if it could exist. And that's a very important thing for us mathematically, because that's going to allow us to find instantaneous moments later on in calculus, what's called a derivative, the instantaneous change in an object. For example, how does a car speedometer work? How does the when the police pull you over, the little radar gun work? It's involving this word if. If we can have an instantaneous moment, what would the exact speed be? But that's a conversation for later. So today we're going to review about limits, a topic again that we're going to bring up throughout this year and that you learned in pre-cal. So if we want, we can think of the value of the function as a house. So if we think of the value of a function as a house, so picture this house here, right here, standing up on the hill. This is the value. You can be at a house. Now, the limit we can think of as the road leading to the house. So when we think about the limit, we are thinking about the road as it approaches the house. Now, preferably, we prefer the road to be on both sides of the house, but that's when we get into more of an exact definition of a limit. So, but if we think of the road as the house, so here's my road here, there's my function, we're approaching the house. Now, if the road leads to the house, that is a special word that we call continuity, a word that you probably again heard last year in pre-cal. So if the road leads to the house, it's continuity. If I give you directions to my house, preferably you're going to wind up at my house. Now, so let's take a look here, down here. The value of a function versus the limit of a function. So here's what we're going to say. The value determines the exact value of a point on a function. So, and we have a special notation for that. We would say this is going to be f of c. The limit asks us what the value is approaching as we get closer to x. What if x could be c? And you might recall this notation. There's two ways we can write it. As x approaches c, what does the function approach? And last year in pre-cal, you talked about this notation. We would say the limit as x approaches c of our function. So what we're trying to find out here is, what are we approaching? If we're on I-10 and you're approaching Houston, you're not at Houston, you're approaching Houston. F of c says, what is the value at that exact point? So this is a value at an exact point. All right, so let's go ahead and take a pause here. We'll go on to another video, and we'll take a look at some examples. I hope you guys enjoyed the video.